So this thing has been one of the handiest supplies for me. Really paid off me putting it together. And it's really just based on the thought of, me having a few drill batteries. You use a drill, you've got batteries that you use. Typically, most people have the same batteries, and they've got a few of them. So they're easily recharged. They put out a lot of juice, and, so it just seems like that's a good idea for a power supply, powerhouse. And the good thing is, typically when you find buck converters, boost modules, things like that, they're usually in the range of what you can find lab supplies to be. So you can commonly find a lab supply that will be about 30 volts, 5 amps. Depends on where you get it, but nowadays that's probably going to run you $50 at the very least. Something like this battery seems to do pretty good. It was just a cheap knockoff DeWalt battery replacement. Basically, the crux of that was just getting this little adapter here. An easy interface to take the battery on and off. Click the battery in, and that is the powerhouse. And basically the stages are, that little voltage indicator there is on a low voltage cutout circuit. So there's basically a little relay there I had to open up to sort of fix because it got stuck before I put it in there. So that little relay is going to shut off once that voltage reaches about 16.4 volts or something like that. And that was just the point at which I decided I don't want that battery to go below that. Probably would be safe for maybe 17 volts, to be honest. So that right there is just a safety measure that will keep the the LVP in place. And then you've got obviously the other initial safety measure of you want a high current fuse coming in from the battery. From there you just got a series of switches to where you go through a boost module to bring the max voltage up to, in this case, about 31 volts. And then you have a buck module, which in this case had my constant current control and all that. That's particular buck module I found to be very resilient. I've run all types of high voltage devices off this thing and haven't had any problems. So that buck module, since it had those current controls, you can see I've just put my own external knobs on there. This is the constant current control, and then these right here are the voltage, to where I've just replaced the pot that was on there with a bigger one, and then threw a smaller value in series with it. So that smaller value obviously is going to be your fine tuning, and the larger value is just your coarse tuning. Obviously constant current is really ideal, and it really helps to have some type of ammeter on the supply to really see what's going on. I chose to have this analog because I felt that was more reliable. In this case, I had to buy a shunt for it to make it accurate. Short the leads together like I have here, and turn the current all the way down, cut the output on. See, got 0 volts, drawing nothing till I slowly crank the current up. So you can see we're up to about 10 amps, something like that. Now, the safety measure here is, it's not pushing too much to pop the fuse. It's supposed to be able to do that, but I really don't want it pushing that for long periods. So that's why I've got this thermal switch that just popped out right here. So I found those handy. That's just a basically resettable fuse. It's a bimetal fuse, so that thing gets too hot and it's in line with the output. It's pushing too much current, as you can see, so it popped out and it broke my outputs. For whatever reason, that thing went dead short. Didn't want it to, then that's going to keep it from damaging anything in there. Pop that thing back in, it starts drawing current again. So, something like that, it's not going to pop out. Very handy device, I feel like. You can see I've just thrown a little USB guy on there. You don't really need that. The only other addition I found kind of handy was you can take another module. I just decided to add another one. It's a step down, so it's another buck module, and that one's set to about 13.5 volts or something like that. And I felt that to be a good output voltage to power most common small inverters, to where it's not too low and it's not too high. So if I plug this little bulb I've got in right there, then of course you can cut that on, and of course you get your inverter output up to a reasonable current. So obviously that comes in handy in a power outage, you could say. Tote it around with you, take it different places. I've used this to slowly recharge my car battery before. There's lots of uses. And of course, once it drains, just unplug that sucker and throw a different one on, and throw this on the charger, just like how you'd cycle your batteries for your drill that you're using on your drill. So here's what the inside looks like. I know which boost modules these are. I've used them a lot and they're pretty cheap, but I can't recall which buck module this is. I just know that this one was pretty robust. So I think it's a 300 watt module that just had voltage and constant current control on it. It's pretty much all I know. Something like this is pretty easy to build where it's safe. You see I've got a fuse that I've bootlegged a smaller one in there. I need a bigger one, but it's what it is for now. The main fuse coming in. I've got a high current connector separating the battery from pretty much everything else. One little separate buck module here, which is just set to a constant output voltage that doesn't need constant current. I want as much current as I can get out of that. And that's powering the cigarette lighter jack, which would be obviously for something like the inverter. That's set to the maximum output. Again, constant currents, no concern there. You just want the highest output voltage. And you're just coming down from there to the buck module, and that's basically the main powerhouse there. And I've actually, never really needed to improve that in any type of way. I just left it how it is. So then you just take your output, just run it through a series of switches. The one switch being right here, the resettable fuse. You got the switch series with the actual output. You want to have that switch there so you can have your settings first and then gauge the output whenever you want. And you've just got this, in my case, it's ammeter, it's analog ammeter, show me what's going on. The LVP board, it's pretty much optional, but I've found that to be a real good safety measure because oftentimes I'll run this thing and it'll just start sagging that battery voltage down way too low, and that'll kick out for me to let me know it's like, all right, I need to recharge that battery. You don't want to damage it. Definitely don't want to damage those batteries. We're talking about you can get these for a few dollars. Something like this, maybe you'll spend $10, maybe 15, 20 on a really nice one. These boards really cheap. So when you really add it all up, the actual build of a power supply like this that's portable and isolated, it's really not going to run you anything close to what an actual lab supply would cost. The only difference is the battery. So again, the point is, if you've already got drill batteries, that's really where that comes in. Replacement battery like that's not actually made by the drill manufacturer. I think that was like $20 on eBay. I've had this one for longer. It's pretty much the same premise. It's just got a lithium pack inside, a pack of lithium batteries. So I have to recharge that using a separate buck module that has a set voltage and constant current. Basically, it's a constant current module that will make sure the battery recharges at a certain rate up to the right voltage, so long as I feed it anything up to like maybe 24 volts, something like that, 28 volts. I've just got a dedicated charger for it, sitting right here actually, and that sits up there like a regular lab supply. It just stays in there, stays charging, and if I want to, I can unplug it and move it around. Again, it's got the onboard little cheap inverter, which again will cut that bulb on all the same, if necessary, run it for a while. So that's just a relatively small lithium bank. It can't deliver the same current that can off the drill batteries, but it's basically got the same functionality. So that's obviously got the addition of a BMS board in there to protect the battery bank. It's also supposed to help balance charge the cells. So that's all the type of stuff that I have to worry about that I don't have to worry about when using the drill battery. And I've also obviously got a charger that came with it. And of course these little voltage modules, they're accurate enough, right? Anyway, I got this fluke meter hooked up just to the output, and it's close enough. You can calibrate them if necessary. Boost module, AliExpress got them cheap, but I've been getting by with a 150 watt module, so long as I don't let the output push about 8 amps or more for long periods. That's what the resettable fuse is for. Actual buck module I've used is this one. This is what it looks like. It's about all I really can say there. It's got CC and CV. Says it's good for 12 amps. So that one's kind of a little expensive, but whatever, $8. It works pretty good. Adapter deal, I paid like $6 when I got it. Everything wants to be more expensive now, but something like that, boom, open it up, and you'll just have easy 2-wire connection basically coming off the power rails. When it comes to the wiring of something like this, I think it's pretty self-explanatory. You obviously want to use thick enough wires, solid enough connections. When you're using these modules, it's pretty obvious you've got inputs and outputs. You know what I mean? So coming off your battery through a switch, whatever, however you want to do it, but you're going into the input of a boost module, then it's got an output coming out, positive, negative, you know, and that's going into the input of the buck module, and that's got an output coming off of it, positive and negative. So boom, there you go, that's your output, you know. So it just makes it real easy to Lego this type of stuff nowadays with these types of modules that are available, which, like I say, has held up way better than you know, $60 lab supply I used to use. It's almost been a couple years now, non-stop use for a good solid year and a half at least on this thing.